Welcome, everyone. Really pleased to have the opportunity to speak with you today about the latest in enabling modern analytics, modern business intelligence, and AI ML projects in ways in which generative AI can help with that. The topic here is optimizing machine learning for business oversight. I'm Kevin Petrie. I run the research group here at Eckerson Group, and I'm joined by Michael O'Connell, Chief Analytics Officer with Spotfire. Quick summary of my background. I lead the research team, as I said, here at Eckerson Group. I have a long background in technology, including the vendor side, running the analytics services team for EMC Pivotal. I was with a data integration vendor, Attunity, which is now part of Click, and got my start as a journalist. Love to write, and that's part of what drew me to Eckerson Group. Michael, why don't I let you introduce yourself?
Sure, thanks, Kevin. Happy to do this presentation with you today. I'm the Chief Analytics Officer at Spotfire. I lead the field tech team, which includes our data science team, visual analytics specialists, architects, and advanced technologists, ATS folks, we call them. I've published a lot of papers, originally did graduate school PhD in statistics at NC State, the home of SAS, and since early part of the career had published many papers, patents, wrote a bunch of software packages, primarily in S+ and R in the early days. And I've been 30 plus years in the stats, data science, computer science world, software world. And I also have an obsession. Mine's a little bit more about data management and analytics, but I do really enjoy your writing, Kevin, and I like to write a little bit myself.
Thank you very much. And likewise, I think this will be a great discussion. So very good. Okay. Well, I'm going to kick things off here. And what I wanted to do was start by talking about what's happening within enterprises. Our founder, Wayne Eckerson, runs a consulting group. We advise a lot of Fortune 2000 or Global 2000 enterprises. And we see that there's a continued and renewed effort to digitally transform enterprises. There's a new kicker to that, which is that moving beyond data modernization, getting onto the cloud, and really embracing artificial intelligence is of paramount strategic importance to a lot of these enterprises. Organizations are recognizing that operationalizing machine learning models, for which there's a pretty extensive set of public libraries now, can help them drive operational efficiency. That can help them create new channels for business and new products as well. One of the benefits of artificial intelligence and machine learning is that organizations can accelerate their interactions. They can remove a lot of friction from the system, and they can enrich their decisions, speed up their decisions. So if you think of a machine learning model that can help identify fraud on a real-time basis, that can help with preventive maintenance of delivery trucks, that can help with preventive maintenance on oil rigs and refinery operations. Those are all ways in which you can improve operations. Now, what's fascinating about the time that we're in here, August 2023, is that organizations can, using generative AI, generate content and insights into operations, into customers, and markets. So generative AI, we're going to talk a little bit about that, is a way in which you can start to understand how concepts relate to each other. You can start to draft content that can help guide organizations through the analytics process, among a lot of other use cases. So digital and AI transformation in all these ways is an opportunity that enterprises are seizing upon to realize new value from data by increasing productivity, by enhancing creativity. So some of the key concepts that we're going to talk through here are artificial intelligence, machine learning, and generative AI language models. Artificial intelligence, to level set us, is software that mimics cognitive tasks that traditionally are the domain of humans. Artificial intelligence makes use of rules, statistical methods that Michael is very deep in, of machine learning, and it enables software and computing systems to have outputs that in some cases exceed what humans are cognitively capable of. Now, machine learning is a subset of AI in which you have models that discover patterns in data. They study oftentimes features within data sets, perhaps streaming data, perhaps data at rest, and starts to understand the statistical interrelationships of those features, those telling attributes within, for example, columnar data. It can define the relationship between those data inputs and outcomes. When you do that, you have a model that can start to predict, classify, recommend what comes next. Generative AI, which exploded onto the scene in November 2022 with OpenAI's release of ChatGPT version 3, has been around for a while, but the power and the speed of it now, I think, is really jarred a lot of enterprises into taking advantage of some compelling opportunities. Generative AI can learn the statistical relationships of words within text documents. Specifically, you take large amounts of text, you tokenize it, which means that you create each word or part of a word or punctuation into a number, and then start to understand all the parameters that describe the interrelationships of those tokens. Based on what the language model learns, it can start to understand and create content. Users can converse with it through a natural language processing interface in order to understand, among other things, and analyze data and manage data. And Michael's going to be talking through that. So effectively, you can have a co-pilot, you can have a very smart robot alongside you as you manipulate data and glean findings from it. So language models are helping interpret and describe analytical outputs for analysts. They're helping data engineers create and document pipelines as well. Here at Eckerson Group, we're doing a lot of research on that, and it is fascinating to see the symbiotic relationship between data management, analytics, and generative AI. All these concepts and all these initiatives are helping enterprises boost, as I said, productivity and creativity. Okay, of course, this is hard to do. It's easier said than done. We all are dazzled by the outputs of ChatGPT or Google's Bard, but we recognize that sometimes it gets things wrong. And that's just one signal of the ways in which AI and ML is harder to perform, harder to deliver results on than one might think. At Eckerson Group, we see three primary types of challenges. And this focus here on out is more focused on building and delivering ML models that are spotting those patterns in data. One of the big challenges is lack of teamwork. There are a lot of silos in data sets, silos in business, silos within IT systems and IT teams, and that can lead to disjointed interactions between individuals and between roles, teams. It can also, a symptom of that is you might have a tool that's very specialized for, let's say, feature engineering, and another tool that's very specialized, it's a notebook for model development. A lot of organizations end up with multiple tools, and they need to learn each one, and they need to figure out how to manage all of them together and integrate them in a seamless way. That can slow things down. This lack of standardization is contributing to that. It can result in artisan projects that are hard to reuse. So organizations will create certain elements, certain artifacts, one model for one project, another model for another project, one set of features for one project, and another set of features for another. And if there's not a standard method of using and reusing reliable, modular, Lego-like components, that can slow things down. So you need collaboration on using standardized reusable elements. And then a third big challenge here is ungoverned models. Models can be somewhat of a black box. That's the term that gets used, and it captures accurately the challenge, which is that if you have a prediction, for example, if an ML algorithm tells you that this individual has a high risk of fraud when they work with this merchant, and therefore you stop a transaction, you need to be able to explain why. You need to be able to explain why to the organization, to the stakeholders, to potentially compliance officers. And so that lack of explainability, that opaque nature of certain models can be a real challenge. Models can also get things wrong. Data can drift. You might train models on a certain business reality, and that business reality starts to change, which means that the model outputs are no longer accurately reacting to the ground truth, the current business reality. There's also bias. So if a certain training set of training data does not accurately represent certain members of society, the outputs also might not accurately represent them. That can create bias, which has all sorts of business and potentially legal implications. So AI and ML initiatives really need teamwork, using standardized elements and platforms, and governance. I do believe that, or a lot of organizations are recognizing they didn't solve the problem of data governance, but they need to redouble those efforts and now extend data governance programs to take care of AI and ML. And so that's an ongoing challenge. ML platforms, machine learning platforms, can help right the ship, can help data science teams manage the life cycle of data and featuring engineering, bringing your data together, formatting it, identifying, for example, within a lot of tabular data, the key columns, the most telling features, the most telling attributes that are going to help dictate, in this example, future customer actions. So you want to define those, you want to refine those engineers, and then you can start, or those features, and then you can start to develop a model. It might well be that in a lot of cases, there are pre-existing models from public libraries, from Spotfire libraries and so forth, that can be applied to features and data sets, but you want to refine it, fine tune it on the specific training data. And once organizations have a model, or more likely a set of models that are performing to a sufficient level, they can start to operationalize those models, put them into production. And production means that you are injecting, let's say, for example, a real-time machine learning model for fraud prevention that could be injected into production workflows. And it's going to, on a real-time basis, recommend or even intervene to halt a transaction. So that's serious stuff. When that happens, you need to govern what's happening in production. You need to model metrics of performance, look for drift, and intervene when necessary to demote one model, promote another that's trained on more recent data, and so forth. So this is a cyclical relationship, as you can imagine, and it's all about creating a set of reusable models that are ready to swap in. If you picture a sporting event where you've got a team of 11 players, my boys like to play lacrosse, you're swapping in fresh players all the time based on who's ready, who's rested, and who's best able to handle the situations on the playing field right then. It's similar with machine learning models. All this is going to run on top of a data platform that collects, potentially streams, and virtualizes data. It needs to integrate with an ecosystem of machine learning tools, libraries, notebooks, etc., and create that interoperability of tools and the portability of data. They're going to feed a consumption layer of applications and workflows, both in production and on a training basis. So the machine learning platform, and Spotfire has a great offering here to evaluate or consider, is helping data science teams manage that life cycle for machine learning models in a collaborative, standardized, and governed way. I talked a little bit about Spotfire already. What you'll see here in orange is the areas that Spotfire has a core offering. Spotfire has a series of capabilities. It can stream data, handle streaming data pipelines, also virtualize data sets to help look at distributed data and interact with it without moving it. And then it's got a complete machine learning platform looking at data and feature engineering, model development, and production. There's a rich capability to visualize and also integrate with ecosystems. Michael's going to be walking through a lot of that. It really builds on Spotfire's heritage in BI visualization. So what I found in evaluating Spotfire compared with some other platforms is that it's helping business owners and citizen data scientists in particular drive the machine learning lifecycle and collaborating with core data science teams. Okay, I want to quickly define who are the players here. There's the business owner. I've got them in a supporting role, but it's a critical supporting role because it's going to provide coaching and oversight, maybe working with an executive sponsor as well, to all the teams, because you need to define your business objectives at the outset. While that's self-evident and a cliche, it bears repeating because most organizations are full of technical people who are excited to dig in and answer the business questions later. You got to answer it at the outset. They're going to work with the data scientist who's going to play lead on all three stages: data and feature engineering, model development, and model production. The data scientist will work closely with the data engineer, especially on data and feature engineering, because the data engineer is going to best understand the processes required to get data into a usable shape, to make it fit for purpose in terms of integrating data sets, possibly looking at it from a virtual lens, reformatting it, filtering it, validating it, and so forth. The machine learning engineer is going to advise through the first two phases and then really kick in with the model production phase, because there's going to be a point at which the data scientist has viable working models, potentially one to go in production and another 5 that are ready to go on the field at any point. And the machine learning engineer is going to kick in and start to put that stuff into production. They're all going to work with DevOps folks to make sure that this is appropriately integrated with production applications. So data science teams need to have a shared approach, a collaborative approach to all this, and they need a shared platform. Okay, so I'll wrap up with this and hand over to Michael by providing what I think are 5 critical strategic questions to understand if you're looking at a machine learning platform. It makes sense to be comprehensive in terms of the capabilities and really use these 5 questions to evaluate which one might work for you. How does this platform streamline the machine learning lifecycle? You want to make sure that you're not limiting or oversimplifying your capabilities to customize, but you also want to make sure that you're not doing too much custom work. You should be standardizing the easy stuff and making it repeatable, reusable. We all love to play with Legos as kids. I certainly did. And if you can do some pretty creative things, but it sure helps that those are reusable modules. Does it foster the right level of innovation and customization? It kind of builds on the point I just made, which is that you want to standardize the easy stuff, but you want to make sure you can customize and innovate and continue to build in a modular way. Does it support cross-functional collaboration? There are a lot of very sophisticated tools that are core for data scientists or maybe machine learning engineers or data engineers on the data pipeline side. But you also want to make sure that business owners, business managers are able to get the views that they need to provide the coaching and oversight. Everyone has, unless you're talking about a company that was born last year or during the cloud boom, they're going to have an existing environment. It's often going to include some on-prem stuff, and you got to make sure how you can get from here to there. So figure out how that new platform is going to integrate with what you have. And then risk is critical. I talked about the risks related to governance, model drift, which can comprise data drift or feature drift. You can also have opaque models that aren't explainable. You can have bias and so forth. And it's going to be critical to have a platform that gives you the right visibility into the right measures of risk so that you can intervene and tweak things as necessary. Good. Okay, so Michael, I'm going to hand over to you and look forward to your thoughts. I think you have a deck that you're going to share here, so I'm going to stop sharing.
So yes, excellent points on the considerations for the platform. And this slide I'm kicking off with is from a report that you'd written where you went through some of the differentiators of the Spotfire platform for visual analytics and data science, along with streaming and virtualization. So just to kind of recap how we fit into that analysis you've been doing of the market, with Spotfire platform, we're able to visualize and analyze each stage of the life cycle, from data exploration to defining features, doing modeling, managing the outputs, and then using Spotfire visualization mods, and data functions to add functionality for enhanced visual analytics in particular for industry specific use cases. And then data functions where we open up the platform for R and Python users to add their own functionality to extend the platform. And the unique part of this is that we look at the parameters of the Python and R data functions, and we automatically generate a point-and-click user interface for the business user to incorporate that along with their point-and-click visualization work. And then, as you pointed out, taking streaming data to take the models and drive real-time predictions, recommendations, actions. This is a key word for us. And then virtualizing the data to enrich the features and allow that to occur. So I'm going to jump into a little bit of this based on Kevin's analysis and how the Spotfire platform lands inside of that. I'm going to dig into some of those points that Kevin has been writing about. Okay, so the Spotfire platform at a high level, the user interfaces and the personas that Kevin was talking about. There's a desktop application for folks to hands-on develop. There's a web application for people to point and click around in guided analytic workflows, and Spotfire apps that are authored by the desktop type user. And then the mobile, if people want to pick up a look at KPIs on their mobile app that are coming out of the visual analytics application, they can do that too. Now, under the hood of that, we have a variety of ways of connecting to the data, like the information services model, the meta layer for connecting into different types of data sources. And you can see pretty much everything is covered there, from on-prem data to cloud computing platforms, data lakes, flat files, web services, whatever you want. So information services takes you down into those and gets you connected with various authentication and authorization services. There's automation, so you can run an automation job on a trigger or on a clock to produce an updated analysis. The web player server allows just someone to, whatever's been put in the analysis, you can click around on that as a casual user from a web browser. And then the data science and streaming services that Kevin was talking about for handling advanced machine learning type modeling and then analyzing data right on the event stream in real time. Now, all of the artifacts involved in that are managed in a library. So the connections to the data, the analyses can be one-click published to the library and shared directly to the web layer. The data functions that I mentioned for Python and R, the visual mods to extend the graphics palette, the models, the rules, the metadata, kind of all in one. It's self-service. So once you stand this up, people can just come on and grab an application environment, or get a web view on a certain analysis, or get a mobile view. It gets high marks for self-service of these sophisticated capabilities. So some of the types of analyses that people use the platform for: self-service, I mentioned, to quickly come and create an analysis or view somebody else's analysis or collaborate quickly. If you want to do, good-looking data viz or dashboard type scenario for different end users, then you can quickly do that. If you want to create a report, like export an analysis out to PDF and burst that out to a bunch of different end users who want to see a report versus an interactive view. The data science piece, as I mentioned, pretty sophisticated and extendable through Python and R, drag and drop, automatic user interface generated, and so on. And then creating analytic apps for specific use cases that typically have high value. You can develop an app, point and click, pretty sophisticated and good looking app right inside of Spotfire. And then if you want to get your mobile BI type user experience, look at some KPIs, quickly understand if you're in the field on your phone, where do I need to sort of hone in on. And then recently we've been adding this idea of actions. So once you see some outliers or interesting points in Spotfire, you can automatically take an action from inside of Spotfire. So the example here was this listen up application we developed, which is one of our Spotfire apps on our community, where we're listening to sound waves coming off a piece of equipment, and we're doing some unsupervised learning here, 3 different types of unsupervised learning to find an anomalous image that's representing the sound wave. Now, when you capture that, you can make what's called a Spotfire action, basically decide from a point-and-click interface how you're going to notify and act on that insight. I found this anomalous sound wave. How do I tell people about it? How do I get them to do something? So you can decide, am I going to send someone a message, an email? Am I going to post this up to a website? Maybe I send this out as a Slack thread. But basically, the tech team is notified, and actions logged to the system, and you can right from inside Spotfire, go from insights to actions. And that's a theme for our upcoming analytics forum, September 19 to 21, is taking insights and turning them into actions. Now, the data science piece is not just that visual piece with the Python and R and so on. You can also create pipelines to run against very big data. So if you've got data that you want to analyze in the gigabytes, terabytes, we have a connection into Spark that allows you to use any Spark engine you want, whether it's Databricks, EMR, Cloudera type things, and go against whatever cheap storage data you might have available, S3 buckets or SAP, Snowflake, ADLS, anything that is covered by our data virtualization offering, actually. And so you can look at those data sets, you can provision those into these point-and-click workflows, and you can also have access to create a Jupyter Notebook Python type analysis to run distributed against those data sources as well. Now, that ability to do that also allows you to write out the result sets through our virtualization layer and to browse those virtual views from inside of Spotfire so that you can, create 3 different personas here that are totally intertwined. You can have the citizen data scientist on the left here in that pipeline. The result set gets written out from this job that might be run on a clock or a trigger. Gets written out as a data set inside of the data virtualization environment, and that can be automatically surfaced inside of Spotfire to do interactive in-memory type analysis. So this combination is very powerful. And as Kevin was talking about, you can also layer in streaming data on top of this, so that as you've built a model, you can then run that model on new data on an event stream or on batch, to basically update your analysis, find the areas of action of interest, and apply that to streaming data and take actions on that. So this is an example of one of our Spotfire apps for dynamic pricing, where you're continually updating the pricing model for deployment and use in offers that you make to customers on certain products. And those models can be managed under the hood and reinvoked and run on batch or event stream data. Now, Kevin has really talked quite a bit about the amazing events of this past year and the traction from large language models, in particular the ChatGPT tsunami that landed in December, I guess. And so we've been working with that to create a Spotfire Copilot. And what we do here is we ingest our Spotfire documentation, and as you're looking at or creating visual analyses, we allow you to have a chat interface to see, well, here's an anomaly, for example. This is an energy sector analysis looking at pressure versus time in a completions or fracking project. You basically, to these micro fractures in the rock, and the pressure goes up and then it cracks and it goes down. That's why it has that up and down view there. But what is, you can have a question here. What is the reason behind high formation pressure? And you can get an answer, and you can basically interact with your graph. Now, there's a number of ways that the Spotfire Copilot is designed to help you in your analysis. For example, just general Q&A. So, what are the top ways to lower dimensionality of a large data set? So a little bit of sort of data literacy type of stuff. And then Spotfire Q&A, like how do I color code a scatter plot by a third variable, or how do I run a data function? Custom conversations. So, how many units of a product did we sell in this quarter based on the data that you have at hand? Interrogating data in Spotfire. So what's my forecasted energy consumption of a certain analysis, or the highest sales over the past years, or even generate code that helps you build some of the aspects of a Spotfire analysis, the data wrangling part, typically. Now, this is a result of a lot of work that we've had going on for many years. And if you look at the evolution of large language models, way back down here, 2013, with the early work on Word2Vec, and getting out into QuickType on the iPhone and Siri and speech recognition, and then transformers really landed, and in 2017 with the BERT model from Google here. And getting up into the OpenAI GPT in 2018, 2019 sort of thing, and then GPT-3, which landed, and then one of the recent ones is the Llama V2 from Meta has now been open source, which is quite a recent significant development. But you can see the branches of the evolutionary tree of large language models. Now, one of the reasons I'm including this is that this bottom left-hand corner piece here with the BERT, that was one of the pioneering transformer models from Google in 2017. We've been using that for quite a while as part of, we're using those embeddings for fuzzy match, and along with SQL over and NLP methods for some of our NLQ work. And this, the NLP toolkit that we've had out for a number of years on our community includes a lot of the data pre-processing that's involved, like removing stop words or doing stemming, computing n-gram matrices, and then doing also named entity recognition, part of speech and sentiment tagging, the sentiment tags, with polarity, subjectivity, modeling on top of the data prep. And so this is, we've done a recent refresh of this, but this is a sort of developer style example here just to show you some of the parameters that you can expose. And so here I've got some Airbnb reviews from the UK. You see how I'm changing the n-gram length, and I quickly get back what are the words that commonly occur in the same document across the corpus of Airbnb reviews in this case. And you can see as I drill in, I pre-specified certain names that I want to, entities that I want to recognize. I've generated a sentiment analysis represented by a word cloud in the bottom right. This is a text card mod on the left, where I've, as you drill around on this data set, you can quickly see individual reviews that match these named entity recognition or these n-grams or the sentiment analysis. So this is sort of a developer-centric one with application or example where we've actually exposed some of the parameters of the NLP data prep pieces, and you can see hands-on sort of how they work. So, we've gone a long way since those early days of setting up the analytics on natural language for prep, data prep and modeling. And we're using that knowledge in the Copilot that we're working on at the moment, so that you can now have a conversation inside of Spotfire and say, hey, show me sales over time. And Spotfire will come back with or find the right data. In this case, there's a column sales total in your analysis that it looks like the best approximation to the question. And then, interpreting that ordered data as a column that looks like it most accurately answers the over time question. And so basically the Copilot will bin the ordered data, the sales total for the categories of ordered data, bin them up, and then choose a line plot to show that data on a chart that best answers this question. So all that work is happening behind the hood. From basically 5 words, you're getting a suggested visualization, and you're also getting instructions about how to do it yourself, or you can just click the thumbnail and bring that into your analysis. So exciting times that you can have a conversation like that with your data in Spotfire and have it help you, create visual analytics like this. So here's another example. What's my highest selling product? The Copilot interprets that product category as the best variable to put on the x-axis for that. And the adding up sales total variable for product category 1, the categories in that variable, adding those up, and then choosing a bar chart to show the differences between the sales of the different products. So quite a lot of stuff going on behind the hood here. And again, a suggestion about how to do that, either through just adding it or through the steps that you might do manually. So what's going on behind the hood here? The prompt engineering buzzword that's out there at the moment. This is not just writing, a piece of language that best maps to the engine or the transformer, pre-trained model. This is being taken to new levels. And in our work, for example, we are starting off by taking the question someone asks, we send that to the LLM, and we get it to understand what category of question that is. And then we have this is a whole bunch of code here in our prompt engineering application, where we will feed back what the LLM says about the type of question that it is into one of these buckets. And then inside of each of those buckets, we have a certain amount of knowledge that we're bringing to the table to help answer that type of question. And we're ingesting all of our Dr. Spotfire community articles, all of our Dr. Spotfire community videos, our documentation, books that have been written about Spotfire, or just product documentation that informs how to answer those questions. So this helps us to not hallucinate. We're basically turning down the volume on the pre-trained data sources, and we're turning up the volume on the Spotfire data sources. So pretty exciting stuff. We've been doing quite a bit of work with the Azure tooling with the Microsoft folks. And one thing I like about this is that if you want to bring your own data into it, your data stays inside of your Azure subscription. So there's just zero issues that, there's been some issues out there about people getting wrong data, or OpenAI learning stuff from your data. If you do it inside Azure, it just that your data stays there, our data stays there too. And so this idea of doing some web scraping or putting your data into blob storage and then preparing that with chunking and indexing using cognitive search, so that when you ask your question from Spotfire into the orchestrator and it figures out how to answer it, and can call into the pre-trained model to help put that forward. Again, turning down the volume on the open and turning up the volume on the Spotfire documentation, you get this answer like I was just showing. But you can add into your own data, get your own industry use cases, add it into the whole thing right inside the privacy of your Azure subscription. So we've been having a lot of fun ourselves, and also in our collaborations with our partners. So Kevin, I'm going to just wrap it up there. There's lots of things we could continue to talk about, but hopefully this is a good primer, at least, for your audience about how the end-to-end data science lifecycle can take you all the way from exploratory data to feature engineering to modeling, deployment on the event stream, managing the combination of data science and visual analytics through data virtualization views, and then how we're really taking that to the next level with the use of pre-trained transformers, large language models, to help you in you get really efficient in how you're building applications and exploring your data. But let me turn it back to you, Kevin, I think, to wrap it up here, right?
Yeah, Michael, great stuff. Thank you very much. I always enjoy working with Spotfire. Just the rich visualizations of everything we're talking about is always brought to bear. So great stuff. And it is interesting. It's helpful to talk to teams that were doing language models before they became cool last fall. The background there is very helpful. And what I also liked is the notion, one of the big trends we see going forward is that to do hard work and to reduce hallucinations and reduce risks related to accuracy and so forth, organizations really need to start directing those language models, and we'll call them in this context small language models, at domain-specific enterprise data. And so doing that both on the prompt and the training side can really help improve accuracy, which is one of the things you were talking through with the Copilot. Okay, so I'll wrap up by talking about the guiding principles that we would give to enterprises to get started on machine learning models. Prioritizing business requirements is critical at the outset, and making sure that data science teams are really focused on, and the supporting data teams are really focused on what matters to the business and will really move the needle in terms of revenue, cost, time, efficiency, and things like that. Defining evaluation criteria is critical. We talked about standardization, we talked about interoperability, we talked about efficiency and collaboration, and how ML platforms can contribute to those things. So organizations need to prioritize their evaluation criteria to align with business requirements. From this, you can build a short list of machine learning platform offerings, and you can start to understand how, for your environment, for your team, your processes, what's going to work. And you can kind of go from there, get into a bake-off and so forth. So I think enterprises should really invest in a machine learning platform that will capture the analytics opportunity of digital transformation and AI transformation. And I think some of those AI copilot capabilities, taking advantage of generative AI, will become a required element of how organizations can manage their machine learning lifecycle going forward.